Welcome to the deep dive. Today, we're going to dig into some really interesting research on prompt engineering patterns.
Right.
And the mission here is pretty clear. We want to stop thinking about LLMs as just simple question answer tools.
Exactly. I mean, they're not just chatbots anymore.
No, we're looking at them as sophisticated, programmable engines.
That's the perfect way to put it. The whole mindset shifts when you realize you can give an LLM complex rules, constraints. You're basically coding its behavior with words.
And these patterns we're looking at give you so much more power.
Immense power and control.
Yeah.
We're talking about everything from getting the model to generate multiple high-quality options to fundamentally improving its ability to reason.
Okay, so let's start with that idea of control. We've got the alternative approaches pattern, which I think is fantastic. It lets you use the LLM's, huge training data as a sort of rapid prototyping engine.
Yeah, instead of taking 3 days to test one idea, you get 4 viable solutions in, 30 seconds?
But there's a problem there, right? A lack of control.
There is. If you just ask for multiple options, the LLM can sometimes just invent its own task.
Like what?
Like suddenly deciding it needs to organize a cluttered desk that doesn't even exist. Something you absolutely did not ask it to do.
Right, it goes completely off script.
Yeah,
So how do we lock down that amazing speed and stop the model from going rogue? We need some kind of order of operations.
that's exactly it. And that's why you have to combine it with a really simple but crucial pattern,
Yeah.
the ask for input pattern.
Okay.
So you define all the rules for the task first, and then you just add one simple line. Ask me for the first task.
So it has the instructions, but it has to wait for you.
It forces it to wait. It can't just run off.
Yeah.
You, the user, stay in complete control of the conversation.
Okay, so once we've got our inputs under control, we need to demand, better quality thinking from the model itself.
Yes.
And that brings us to the cognitive verifier pattern. This one feels like a real game changer, especially if your question is a bit vague.
It forces structured logic. You're telling the LLM, don't just answer me. First, figure out what other questions you need to ask to answer me well.
I see. So it generates its own sub-questions.
Right. And only then does it combine those answers for the final response.
Like that classic example, asking how many mosquitoes are in my front yard.
Exactly. A bad model just gives you a random number.
Yeah, 500.
A model using this pattern will ask you back, okay, well, how big is your yard? Or are there any sources of standing water?
That's so much better. It structures its own reasoning.
And that structure moves you from just a wild guess to a defensible estimate, like a few dozen to a few hundred. And this whole focus on internal logic, it leads right into chain of thought prompting.
Chain of thought. This is where you explicitly show the LLM the reasoning steps before it gives you the final answer.
Or ask it to show its work, yeah. And it just dramatically improves accuracy because you're forcing it to apply common sense, which LLMs famously struggle with.
There's that great zero gravity example.
Oh, it's perfect. You ask if a cup knocked over in a spaceship lands on the floor. Without chain of thought, the model often just says yes.
Because knocked over and lands on the floor are always tied together in its data.
Exactly. But when you force it to show its reasoning, to think about physics, gravity, what on the floor even means in that context, it gets it right.
And the answer is no.
The answer is no. It has to clear that logical hurdle first.
Okay. Finally, let's talk about tailoring the output. The audience persona pattern is so important for knowledge transfer, especially for you, the learner.
It is. I mean, instead of writing pages and pages of rules about tone and complexity,
Right. Use simple words, don't use jargon.
you just give it one powerful instruction. Explain X to me. Assume I have no background in computer science.
And it just gets it.
Instantly. It customizes everything. It'll swap the jargon for an analogy like comparing an LLM to a virtual writer. You've just replaced 10 pages of guidelines with one single sentence.
It's just so efficient. What really stands out to me here is that these are all building blocks. They're not rigid formulas, but like modular instructions you can combine, like linking alternative approaches and ask for input.
And that's how you solve increasingly complex problems, and you do it faster than ever before. These tools are evolving all the time, but understanding these fundamental patterns for control, for logic, for output, that's the enduring skill.
That's the foundation.
It is. So for you, the learner, the final thought is really just this practice. You have to experiment. This space is brand new, and actively testing these patterns, combining them. That is the only way you're going to ride this wave of discovery and really unlock what these things can do.